Welcome to physics class, and we have a situation where a ball is kicked from the ground at the speed of 19.5 meter per second. So the chapter is about projectile motion. So two dimensions. So projectile motion is an object that is thrust in the air with only influence it has its gravitational force. So the angle of 45 degrees and the player is 55 meters away. And what is the average speed that the player has to run to catch the ball? So the time there, which is the ball, so we need to know the time the ball hits the ground. So that's our key information. And knowing the time, we'll have to know that when it hits the ground, the height is 0. So which means the vertical height is going to be 0, and we have initial velocity there, that is 19.5 meter per second. And we also have change in displacement. The player is 55 meters away. Okay, and then we know that the angle of launch angle is 45 degrees. And then we have a change in y, which is the actual equation. That's initial velocity multiplied by sine theta multiplied by time minus a half multiplication of gravitational acceleration multiplied by time squared. And we know that this equals to 0, so that means that half g time squared is going to be initial velocity times sine theta multiplied by time. So dividing both sides by t, so the t cancels, and t there is going to be t, 2 into t squared is t. So we have an equation that states that t, according to this equation, is going to be 2 times initial speed multiplied by sine theta. So the theta is the angle of launch, and that is divided by gravitational acceleration. So that will give us a value of 2 multiplied by initial velocity is 19.5 meter per second and meter per second, and multiplied by sine 45 degrees. 45 degrees is our launch angle. All of that divided by gravitational acceleration, which is 9.8 meter per second squared. Okay, per second squared. So the meter cancels out, so we are left with a second. So we multiply sine 45 degrees multiplied by 19.5 multiplied by 2 divided by 9.8 gives us 2.81. So 2.81 is our time that the ball will hit the ground. So the person has to reach there before the 2.81 second. So which means that taking it exactly at 2.1 seconds, so we have horizontal speed, which is initial speed multiplied by cos theta multiplied by time. So initial speed is 19.5 meters per second multiplied by cos, our angle of our launch is 45 degrees multiplied by our time the ball will take to reach the ground is 2.81 seconds. Seconds cancels out, so we're left with meters. So that will be 19.5 multiplied by cos 45 multiplied by 2.81, giving us 38.7 meter. So that's the distance that the person will have to run. So what will be the actual speed? So the actual speed will be that, okay, so that will be the difference. So the difference will be 38 meter per second. 38.7 meter, which is horizontal coordinate minus horizontal coordinate of 55 meter as well, and all of that divided by time, which is 2.81. So that will mean that from 55 to what will be the difference? The difference would be negative 5.8 meter per second. So negative 5.8 meter per second to reflect as an average. So the negative sign means that the person will have to run in the opposite direction. So the opposite direction on which the ball is running. So the opposite side at 5.8 meter per second. So that's the average speed. I just want to say thank you so much for watching this tutorial video, and if you can also watch other, I've also included other videos of of projectile motions on the channel. You can have a look at them and see which one you'd be interested in. And this is your tutor, Black Adam. So it's Black Adam 5D tutor. Thank you so much for watching, and don't forget to follow, subscribe. Thank you.